Hi, so we continue an example for multinomial logit model. So the model is to fit the party on three variables, the income and the education and age. So here the education is originally the categorical variable with 7 levels, but that makes the 6 questions. So the model becomes too large. So just for demonstration purpose that we make it the numeric. So it makes still sense because this education variable is the ordered from middle school graduate to the graduate school graduate. So we have the 7 levels, so ordered. So we just make it as numeric, so 1 to 7. Then this becomes, so the estimation result is basically here. So we have two models. So one is basically the probability for independent over probability for Democratic, and the probability for Republican over Democratic. So we have these two. So basically the log of the probability of the independent over probability of the Democratic Party. And this is equal to, the intercept is negative 1.18. So negative 1.18 plus the 0.0162 times income, and plus, oh, actually minus the 0.00229 times education, plus 0.000241 times age. So this is the model, and the next one, the log of probability of Republican over probability of the Democrat. So that is the in the same way. So these are the estimates, and you can see the standard error in the same way. For example, if you see this as numeric, the standard deviation for this, that is this one. And yeah, this isn't really large. I think standard deviation is larger than the coefficient. So if you take the ratio, so this becomes almost 0. So it's insignificant. But for example, maybe income. So this is significant because the standard deviation is much smaller. So Z value for income is 0.0162 over 0.00308. So this is almost about 5. So you can see this becomes significant if you calculate the p-value. P-value should be much less than 0.001. So you can test the coefficient in the same way as logistic regression, even though the table does not show it. Yep, and this is the basically logistic regression. So you can calculate the log likelihood and AIC and so on. So deviance is negative 2 times log likelihood, and AIC is the plus the number of parameters times 2. So this is the negative 2 log likelihood plus 2p, and p is the number of parameters. So number of parameter is actually 8, right? So this is 8. So we have the 2 by 4, so 8 parameters. So that becomes 2000. Yeah. So this is how to read the result, and you can we can also get the fitted values. So the R is convenient, so you don't really have to do anything, and just the fitted value of the model. And this is the first 3 lines. So first observation, the probability for Democrat is 59.5%. And the probability for independent is 18.8%, and the Republican, the 21.7%. And the second person, maybe the more towards the Democratic, and the third person, maybe a little more towards the Republican. Yeah. And you can by using the definition of this multinomial logit model. So at first we extract the coefficient bi, b1, and the coefficient b2. So that is the coefficient we have studied in the previous slide. Then to calculate the fitted probability and predicted probability, that we can use just the x values. So the first line, we have the income, education level, and age. So income, education level, age, And the first one is coefficient. So we multiply this by 1 and this by 1.5. And this times 3.0 plus this times 36. Then we can get so-called eta. And remember that the probability is the exponential of eta over 1 plus summation of all exponential of eta. So that means that we have to calculate eta for the second group. So this eta is for independent over democratic. And this is the Republican over democratic. So using this, that we can transform in this way to calculate probability of independent. And we calculate this as probability of Republican. Then we can get the same numbers as here. And the remainder, 1 minus the sum of these, becomes the probability of the Democrat. Yeah, so now that we try to drop the unnecessary variables. So we have seen that the educational level probably does not matter because the income is very significant, but the educational level isn't really significant from the previous page's output. So we can apply the stepwise procedure to drop variables, and actually only income remains. And the AIC improves by 7, not a lot, but still better than 2000. And yep, so actually our final model is just this. And this is the comparing the independent to Democrat and Republican to Democrat. So testing can be done in the same way as usual. So the difference between the deviance, or a difference between -2 times log likelihood, follows chi-square distribution. This is asymptotic results, so approximation, but this still applies because this has the likelihood function. And here, the chi-squared sub d, and the d is the difference in the number of parameters of the two models. And if you use the deviance function, we can extract that quantity that is 1.45. And that we have the 2 degrees of freedom. So we dropped 2 variables. So small model, we only have income. And large model, we have age and educational level and income. So we have the 2 variable here. So d is equal to 2. And the chi-square distribution with df2 has expectation of 2. So 1.45 isn't really the extreme value, isn't really large value. So we can expect that the p-value isn't significant. P-value is actually 0.484. So it's not, probably it's not necessary. So model only with income is not rejected against the full model. And this is the predicted probability curve based on the model, the best model. And this is the income. The x-axis is income, and the y-axis is probability. So for Democrat, the income is higher. The probability of the supporter is declining. And the Republican and independent, it's higher. And you can see that actually this Republican, no, the independent, independent is always lower than either Republican or Democrat. So if we think about the largest probability as the predicted value, the no observation is predicted as independent. So basically, this part predicted as Democrat. So if income is probably less than like 50,000, then it's predicted as Democrat. And the higher than that, the Republican. And the independent always lower than either of these. So no one will be predicted as independent from the income variable. Yeah, and the code for the predicted probability curve is here. So basically, we have to do prediction for the new values of income. So we have to set up a new data set. Then we have to make a prediction. And in our predict function, always the data frame should have the same shape as original data. So original data, actually we have 4 variables, but anyway, so we only have to use the income variable. So we have to have exactly the same name, income, and it has to be data frame. Then the new data is that data frame, then that we can predict the value. So original, the model is estimated by some data points from 944 data points, but now that we plug in the income equal to $0,000 to $110,000. So we have to put new values. So we have to specify the new data. Then type probability. So we have several ones and several types of the prediction. And then this is the predicted value. So Democrat and the Independent and the Republican. So this is just the line number. So the first one is the income of the $0,000, and the second one $1,000, and up to we have the 110. So that should have 111 lines. Yeah, and again, we can use the matplot to make the previous figure. Yeah, so predicted probabilities are useful, but to see the entire result at a glance, a contingency table for prediction is useful. So we have 3 categories, and we have predicted values and the actual values. So predicted class is a Democrat, Independent, and Republican, and actual the party identification. So that we can compare this with 3x3 table, then we can see the result at once. And usually they classify observation to the class with the highest probability. So if the probability of the Democrat is 0.4 and the probability for Independent is 0.1 and Republican 0.5, we have to assign the Republican for that observation. So that is usual way to classify. But however, if the loss function is not symmetric, then you may set different rules. So for example, the categories different. So category, for example, the categorizing an actual, the malignant patient in medical data into a benign group may be too risky, even if probability is 40%. So if that decision is too risky, maybe we set the threshold as 10%. So more than 10% chance of malignancy, then we classify them as the malignant. Useful if the loss function is asymmetric. So 2 errors are not the same. Yep, and that can be done by just the xtab function. And here predict without any option. So no probability option. Then the predicted values are just categories, either Democrat and Independent or Republican, so that we can make this table. So basically this part, this part, this part. So this is the correct answer. And the other part is incorrect. So these are not correct. So in terms of proportion, that is 284 plus 149 out of all observations. So 6.9% correct. So yeah, that isn't very good, but anyway, we only used the one predictor, so the performance isn't that good. Yeah, so this is the example for multinomial logit model.